Now I'll go ahead with the first step of the assembly of the quadruped robot. I have already downloaded the manual to this tablet. Took a couple of steps getting it downloaded and unzipped, and I have found the first step of the assembly process. Before that, there are instructions on how to program with the Arduino IDE, and of course now once I'm done with it, it will be easier to program, even easier to program with Visuino, and also some information on how to connect servo to this shield or expansion board right here. We'll need to connect the servos in order to zero them. So now let's go ahead and try to figure out what we do in the first step. For this step we'll need 4 M3x10 bolts. They are conveniently labeled in this bag, and 4 brass copper pillars, double pass copper pillars as they call them. We also will need this plastic chassis part here, and I'll have to cut the back with plastic parts. To take it out. So it appears to be this part here. Put the rest of the parts aside. We also will need this shield or expansion board. I will also take it out from the protective back, the anti-static back. And I'll take a look at it. So seems like there is some leftover, though not a lot of residue, from the washing of the flux. They say that the robot should require 2 batteries, but it seems like it requires only 1 rechargeable battery. I should have this type of battery. So yes, this is called Acebott Spider Shield version 1.0, and it has connectors for the servos here. So I'll put it back into the anti-static bag for a bit later, and we'll go ahead with first step, peeling the protective layer, as always with plastic parts. The acrylic plastic parts, I'm not sure, this does not appear to be acrylic, this appears to be some kind of other type of, oh no, it's acrylic, yes, it's acrylic. Okay, well, we peeled it quite easily, starting from one corner. This side is done. Try to find a loose corner, found one. Yes, this plastic type of cover is much easier to remove, it seems, than the paper one. So this one is clean from the covers, nice and shiny. Let's see, it appears to be fully symmetric, so there is no up and down side. So I can pick any of the sides to be the upside. It seems, yes, everything looks perfectly symmetric, actually totally symmetric in all directions as far as I can see. So I'll pick this one to be for now the upper part, the upper side. I'll need 4 bolts as listed here. Leave the rest of the bolts aside for later. Need 4 pillars. There appears to be one probably spare here, so we'll see. but most likely they conveniently have given us one spare, just in case. And I do occasionally lose some bolts and nuts, or maybe even pillars, so it's nice to have a spare. So now we have this switch. We place the board like this with battery holder on the bottom, switch on one side, and align the holes, protrude bolt from the bottom, place pillar on top and loosely tighten. Do not over tight, so we can allow them to adjust at later point of time. Go diagonal. Repeat the same procedure. Now start the second diagonal. The reason we go diagonal is to allow any tension to be released. Mechanically, this is the best approach, and we do the last one. For now, I will tighten them very loosely, because when I put the next board I want them to be able to adjust a little bit, and finally I will tighten everything, reducing any potential tension. So this step here is now completed.